Section 2.6, number 71. We're given this cubic x cubed minus 3x squared minus x is greater than negative 3. So we want to find the x's where this thing is true. Now we know that cubics can have as many as 3 zeros. So this thing might have a couple of regions where this is true. Now, it says to graph this and check. I don't really want to graph this. I like zeros because zeros are on the x-axis. They're much easier to find. So if I add 3 to both sides, right, what I'm going to get is I'm going to get x cubed minus 3x squared minus x plus 3 is greater than 0. That's going to be a much easier thing to try to graph and figure out what's going on. In fact, if I graph it, I'm going to get something that does this. It's going to cross at x equals negative 1, x equals 1, and x equals 3. And if we're greater than 0, that means we are above the x-axis. We are above the x-axis between negative 1 and 1, right? So I would expect x between negative 1 and 1. And we don't want the equalities because the equalities are 0. And above the x-axis, I'd have x greater than 3. So these are the things that I am expecting. Okay? Can we get those things algebraically? Fortunately for us, this is of a form that we can actually do that. It doesn't really look like it off the bat, but we can. So this thing, it's not of quadratic type. It doesn't have something that can be pulled out of every term. But if we look, I have 2 terms that have x squareds in them. And if I look at this term, if I pull if I see this as plus a negative x, okay? If I pull a negative 1 out of here, I might get something that I can then do a second factoring step. So let's pull out our x squared. So we're going to get x squared times x minus 3. Okay. If I pull a minus out of this thing, I'm going to get a minus x here. If a plus, I can think of as a minus a negative 3. So if I pull a negative out of here and a negative out of here, I'm going to have minus x minus 3 in that term, and that's going to be greater than 0. All right. So now, my factoring, I can pull an x minus 3 out of both terms, right? This is a minus 1 times, there's 1's floating around everywhere. So you get x minus 3 is x squared is the remaining term here, and a minus 1 is the remaining term there. All right. This can be factored again. This is a square and a square. So I can turn this into x plus 1 times x minus 1. Okay? All right. So now, positive. We have 3 things multiplied together. How can I make them positive? Either all of them are positive, or 2 of them are negative and 1 of them is positive. Those are the only conditions that I can get. Okay? All right. Well, let's look in the easy case, if they're all positive. So that means x minus 3 is greater than 0. So if I add 3 to both sides, this is going to give me x is greater than 3. Okay. X plus 1 is greater than 0. That means x is, we subtract 1 from both sides, x is greater than negative 1. Okay. Well, it has to be greater than the greatest. So that's this thing. It has to be greater than 3. Right. So this one doesn't really give us any extra conditions. and x minus 1 has to be greater than 0. X minus 1, when I add 1 to both sides, x has to be greater than 1. Right? So x has to be greater than negative 1, 1, and 3. That only happens when x is greater than 3, which is one of the conditions we expected from the graph. Anytime we're above 3, all of these things are positive. All right. Now, the other condition is if one of them is positive and two of them are negative. That's going to be a bit of a problem. Okay? But if we look at each one of these terms, right, this thing is positive when we're greater than 3, but it's negative when we're less than 3. Right? This thing is positive when we're greater than negative 1, but negative when we're less than negative 1. And this thing is positive when we're greater than 1, and negative when we're less than 1. Okay? So what I can do is I can kind of break up my number line. This is, I guess, kind of an advanced technique, right? If we're 3, right, we have a plus, and a plus. Right? For the 3. Sorry. My brain just went off for a second. Okay? In between 3 and 1. Okay, let's do x minus 3, x minus 1, x plus 1. Okay? If we're between 1 and 3, x minus 3 is negative, right? We're less than 3, or 2, or 0, or anything like that. 0 minus 3 is negative, so this thing is negative. We are greater than 1, right? So we're again like 2. 2 minus 1 is positive. So that one's positive. And we're certainly greater than negative 1, so that one's also positive. So you have a negative times a positive times a positive. That's an overall negative, right? Positive times a positive times a positive is an overall positive. In between negative 1 and 1, x minus 3 is still negative. But x minus 1 is now negative as well. If x is 0, right, 0 minus 3 is negative 3. 0 minus 1 is negative 1. So that one is also negative. But 0 plus 1 is positive. So we have a negative times a negative, leading a positive times another positive is a positive. So we're positive between negative 1 and 1. We're negative between 1 and 3. We're positive past 3. Beyond negative 1, say like negative 2, well, negative 2 minus 3 is negative 5. That's negative. Negative 2 minus 1 is negative 3. That's also negative. Negative 2 plus 1 is negative 1, and that is also negative. So in this region, we are negative. The beauty of factoring is that we get regions like this. Right? This x minus 3 is negative up until it is positive. This x plus 1 is negative up until it is positive. This x minus 1 is negative up until it is positive. So we have these 3 points determined by these zeros that will determine whether things go from positive to negative. It's a polynomial. The only way to go from positive to negative is through a 0. So look at the zeros, look at the regions between the zeros, and we're good. Okay? It might be a little complicated, but it's going to work. Or you could just look at the graph and say, hey, if I find my zeros, I look where it's positive, I'm in good shape.